Okay, here's a trickier question that you can get in this module, algebraic expansion and factorisation. We need to expand out two different sets of brackets, then gather up like terms, and then we need to actually factorise it again and put it in this form. So the way to start is, don't worry too much about this side of the equation, but let's try and tidy up this side and get it looking something like that. So I'm going to expand out here. I've got 3ab times ab. That'll give me 3a squared b squared, because a times a is a squared, b times b is b squared. And then I need to do this whole term multiplied by this one. So the 3 2's will give me 6. And a and b times b squared is b cubed. Now to expand out this set, don't forget that this negative sign goes with the 6b squared. So this will actually affect this sign in the middle here, as well as the first one. So minus 6 times 2 is minus 12, and b squared times a squared is a squared b squared. And minus 6 times 3 is minus 18, and I've got b squared, there's 1a, and the b times the b squared will give me b cubed. And all of that will still equal all of this. You can write it out again if you like, or you can sort of just work on this side and get it looking something like this side. Alright, next thing is to check whether any of these are like terms and you can gather them up. I can see here that I've got 3a squared b squared minus 12a squared b squared. So I can gather those up and say that I've got minus 9a squared b squared. So I'll start by just putting the first term I have down. I'll start with this one because it's a nice positive one. Then I can put my minus 9a squared b squared and subtract my minus 18 ab cubed. Now I can see that these are actually like terms as well. I'm just doing one thing at a time there. So if I've got 6ab cubed and I subtract 18ab cubed, then I'm going to have minus 12ab cubed. So this side equals the same thing as all of that. I'm not going to bother writing it this time. I have minus 12ab cubed minus this part equals all of that. Now at this point, that does not look like what I'm going for. It's been factorised. It's got common factors out the front and then some a's and b's inside the brackets. So looking at these two terms, I need to think, what do these two terms have in common? Well, minus 12 and minus 9, that's both part of the 3 times tables, or we could say the minus 3 times tables. So bringing something out that they both have in common is negative 3. They've both got at least one a, and they've both got at least a b squared. So I'm going to bring all of that out the front. Now I have to think this times something gives me that. So we're basically finding the other factor that goes together with this to make this term here. Now minus 3 times 4 is going to give me minus 12. A times 1 gives me a, so I don't need any a's. And the b squareds are close, I just need one more of them. Now thinking about this term multiplied by something needing to give me this term, I need positive 3, because when I expand that out, then I'm going to have negative 3 times 3 to give me minus 9. And I need another a in it, so that when I multiply these two, I get my a squared. And that's all I need, because it already has a b squared in it. This is now looking quite a lot like what we were asked to find. And we can pretty much just read off the chart here and say, all right, minus 3 must be m. And 4 must be, well, 4 is the number of b's, so that will be the big B. And the number of a's is 3, so that will be capital A. Now, there is actually one other way that you could have done this. Let's just say I'm going to choose a different colour. When I'd factorised this, what would have happened if I hadn't brought minus 3 out the front? What if I just brought 3? So let's write this as an alternate solution down here. If I'd said I've got 3 out the front, then and I'd still have the a and the b squared, inside my brackets I would have had to have minus 4b and minus 3a. Now, is this still going to be possible? Does this still look like mab squared, big A, big B, B? Well, yeah, it actually does. but the difference here is that M would have to be 3. Can you still see that? Yeah. And looking at how many A's we have to work out what capital A is, the number of A's we've got is -3. And the number of B's we've got, that's big B, the number of B's we have is -4. So there's actually 2 solutions here. Now, which one's better? Well, I'm guessing that this one is probably the one that they have listed in your textbook. And the reason is putting numbers inside the brackets that are positive looks sort of tidier. But it's important to understand that this one is actually not wrong. And if you got this as an answer, you are actually doing the right thing and knowing what you're doing.